last class we started talking about direct variation. And remember, direct variation is just a special type of line. Whenever I say the words equation of a line, you would respond y equals mx plus b. Whenever I say the equation direct variation, you say y equals kx. So what's special about direct variation? How do we know something's a direct variation? Well, b has to equal 0. What does b stand for? The y-intercept. So last class we did a few of these problems, but I'm going to go back over a few just in case we're okay. To make sure we're okay, excuse me. So if I look at number 4 on this picture, how do I know that number 4 is not a direct variation? Well, I know it's not a direct variation because b does not equal 0, b equals 3. So this is no, because b does not equal 0. Okay? How about number 5? No, because it doesn't pass the origin, because b does not equal 0. Well, how about number 6? It passes through the origin, so yes, because b equals 0. So since b equals 0 and I said yes, I have to determine the constant of variation. So the variable for constant of variation is k. And how do we find k? Well, we do rise over run. So rose 1, ran 1, 2, 3, 4. So k is negative 1 over 4. So let's look at the next one. 7. Is it a direct variation? No. Why? B does not equal 0. How about number 8? Well, yes, because it passes the origin. B equals 0. So because we said yes, we now have to find k. K is the same thing as slope. How do we find slope? Rise over run. So I rose 2, I ran 3, so 2 over 3. And the last one, is it a direct variation? No. Why? Because b does not equal 0. Okay? So now what happens if I give you an equation? If we take a look at an equation, I know something's a direct variation or not if b equals 0. Okay? So we did 1 and 2. Let's look at 3. Y equals negative 1 over 3x. Is this a direct variation? Yes. Why? Because b equals 0. So notice my directions say if yes, state the constant of variation. Constant of variation is a fancy word for slope. What's the variable for slope? K. Okay. So looking at this picture, what does k equal? K equals negative 1 over 3. If you look at number 4, can I immediately tell if it's a direct variation or not? No, because y is not by itself. So I have to get y alone. So I'm going to subtract 2x first. So I have 3y equals negative 2x plus 6. I'm now going to divide by 3. So before I even simplify this, can I immediately tell that this is no? Yes, because I have this value right here, which is a constant. So no, because b does not equal 0. Okay. How about number 5? How does number 5 look different than what we've seen before? Well, we've never seen x on the bottom of a fraction. Y equals kx is y equals k times x. This says y equals k divided by x. Is dividing and multiplying the same thing? No. So is this a direct variation? No. X must be on top. Okay? So go ahead and pause this video, and I want you to try the next 5 examples on your own, and then unpause the video and we'll go over them together. So number 6 is yes, because b equals 0. So k equals 4. I could say 4, or I could say 4 over 1. It's up to you. Look at the next one. Is that a direct variation? No, it's a Vux line. Vux lines have an undefined slope. It is not a direct variation. The next one I would have to solve for y. So I have y equals negative 5x. So k equals negative 5 over 1. So yes, b equals 0. Y is because b equals 0. If I look at the next one, I got to get y by itself, so I'm going to divide by 4. So y equals x over 4. Is this a direct variation? Yes, because x is on the top and b equals 0. So k equals 1 over 4. And if I look at the last one, number 10, is this in the y equals kx? No, because there's no slope. M equals 0. M can't be 0 for it to be y equals kx. Okay? So now let's talk about writing equations of direct variation. So let's go ahead and highlight this. Whenever it says, how do I write an equation of a direct variation? What is the equation of direct variation? Y equals kx. And y equals kx, which letter turns to a number? K. So I'm going to replace k with a number and write y equals kx. Okay? So if we look at these examples, it says write the direct variation equation given the constant of variation. Constant of variation is a fancy word for slope, and the fancy letter for slope is k. So whenever you see the word equation, your brain has to go, my answer is going to be in y equals kx form. So notice k equals 2. So I'm going to write my equation by saying y equals 2x. And if I look at number 2, k equals negative 5, if I want to write an equation like the direction says, I'm going to say y equals negative 5x. Okay. So now let's do the next one. K equals 1/2, so y equals 1/2 x. Another way I could write this is y equals x over 2. And the last one, y equals negative 3 over 2x. And if I wanted to write it, I could say y equals negative 3x over 2. Whenever it says write an equation, it has to be in y equals kx. Okay? So look at these examples. It says, what is the constant of variation when y equals 12 and x equals 2? Constant of variation is the exact same thing as k. So I'm going to write my direct variation equation, which is y equals kx. And I'm going to plug y in for y and x in for x. So I'm going to come up here, and I'm going to plug 12 in for y, and I'm going to plug 2 in for x. So now I want to find k, so I'm going to divide by 2 on both sides. So k equals 6, and I'm done. Next one, what is the constant of variation? Constant of variation is a fancy word for the letter k. So how I find k, I write my equation, y equals kx. I plug negative 10 in for y, and I plug 5 in for x. So negative 10 equals k times 5. How do I get k by itself? I'm going to divide by 5 on both sides. So k equals negative 2, and I'm done. Okay? So now let's get to some of these problems. It says write an equation of variation. So I see this word equation, so I know I have to write y equals kx. When y varies directly with x. I want you to highlight where it says y varies directly with x. Whenever you see those words, you need to write y equals kx on your paper. So when y is 9 and x is 3. So in order to write my equation, I need to know what k equals. So how do I find k? Well, exactly like I did in 1 and 2. I'm going to plug 9 in for y and 3 in for x. So 9 in for y, 3 in for x, solve for k, k equals 3. Now, if I circle this, it's wrong because I want the equation. This is not the equation. So the equation is y equals kx. So I'm going to plug in y equals, instead of using k, I'm going to use the number, which is 3, and then x. And I'm done. Let's look at the next one. It says write an equation of variation when y varies directly with x. I see the word varies directly. I immediately write y equals kx on my paper. In order to write an equation, I have to find k. How do I find k? I plug 26 in for y and 2 in for x. So, divide by 2 on both sides. K equals 13. If I circle this, it'll be wrong because that's not an equation. My equation will be y equals 13x. So go ahead and pause this video, and I want you to try 5 and 6 on your own, and then unpause so you can see the answers. So here, y equals x, or 1x. And over here, y equals negative 5 over 2x. Okay? When I'm looking at a table and I want to determine if a direct variation exists, I must find k. If k is the same for all of the values in my table, then I'm going to say yes, a direct variation exists. So whenever I have a table, I'm going to come and I'm going to add a new row. And I'm going to add down all of these rows. And I want to find k. So how do I find k? Well, I write y equals kx. I plug 5 in for y. 1 in for x. Divide by 1. What's k equal? 5. Now I'm going to move and do the next one. Plug 10 in for y. 2 in for x. My pen will work. Divide by 2 on both sides. I get k equals 5. I'm running out of room, so I'll erase this. And I'm going to keep going. I'm going to plug in 15 for y and 3 in for x. And then I'm going to divide by 3 on both sides. And I get 5. And last one, I'm going to plug 20 in for y and 4 in for x. I'm going to divide by 4 on both sides, and k equals 5. So notice on this problem, your k value is always the same. So because it's always the same, you're going to say yes, a direct variation exists. So I'm going to say yes. And then it says write the equation, y equals kx. So y equals k was 5, 5x. Okay? If we look at the next one, I'm going to do the same thing. I'm going to add my extra row. I'm going to find k. Anybody pick up a trend with k? All you're taking is your y value, which was, let's say, 15, and you're dividing it by your x value, 15 divided by 3. At y divided by x, y divided by x, y divided by x, and that's how you find k. So if you don't want to do all of this work, you can just remember y divided by x. So a quicker way to find k is y divided by x. Okay? So negative 2 divided by 3 is 2 divided by 3. How do I find k? Y divided by x. 0 divided by negative 1 is 0. Now notice these two k values are different. So because they're different, does a direct variation exist? No. And I'm done. Let's now go to number 3. Got to find k. So I'm going to add a row onto my table here. How do I find k? Y divided by x. So 1 divided by 2 is 1 divided by 2. 1 divided by 4 is 1 divided by 4. Stop. What do you notice? These aren't the same. So does a direct variation exist? No. Okay. Let's try the next one. Now my table's vertical, and that's all right. So add on. Okay. So how do I find k? Y divided by x. 36 divided by 2, 18. 54 divided by 3, 18. 90 divided by 5, 18. Does a direct variation exist? Yes, because all these values are the same. So now I have to write my equation, y equals k, which is 18x. Okay? So go ahead and pause this video and try 5 and 6 on your own, and then unpause it so we can go over it. So I'm going to add my row. 6 divided by 3 is 2, 4 divided by 2 is 2, 10 divided by 5 is 2, 8 divided by 4 is 2. Does a direct variation exist? Yes. Y equals 2x. And the last one. Find k. How do I find k? Y divided by x. 16 divided by 2 is 8. 24 divided by 3 is 8. 60 divided by 5 is 12. Is this a direct variation? No. Why? Because your k values do not all match. They have to all match in order for a direct variation to exist. So you have a bunch of practice problems 1 through 5 that I want you to go ahead and practice on your own, and then you can check the answers on Google Classroom, or we'll go over them in class.